Welcome to our potent video on the principle of mathematical induction.
What is mathematical induction?
Mathematical induction is a powerful proof technique used to establish the truth of an infinite number of mathematical statements. For example, 3 plus 7 plus 11 plus up until the quantity of 4n minus 1 is equal to n times quantity 2n plus 1. The principle of mathematical induction has 3 steps. Step 1. Base case. Step 1 is known as base case. It involves proving that the statement holds true for a specific starting value, usually the smallest value of the variable. Step 2. Inductive hypothesis. Step 2 is known as the inductive hypothesis. It assumes that the statement holds true for an arbitrary value of the variable, usually denoted as k. Step 3. Inductive step. Step 3 is called the inductive step. It involves proving that if the statement holds true for k, then it must also hold true for the next value k plus 1. By combining these 3 steps, we can establish that the statement holds true for all values of the variable.
Now let's proceed to the example number 1. We need to prove the following statement using mathematical induction. So for all n, which is an element of n, so we have 1 plus 2 plus 4 plus 2 to the power of n is equals to 2 to the power of n plus 1 minus 1. So let's proceed the proof using induction. We have the base case, which is n is equals to 1. In this case, we have that 1 plus 2 to the power of n is equals to 1 plus 2, which is equals to 2 to the power of 2 minus 1. And we therefore prove that the statement is true. We have the inductive hypothesis. Suppose that for some n, this is element of n, we have 1 plus 2 plus 4 plus 2 to the power of n is equals to 2 to the power of n plus 1 minus 1. So for the inductive step, consider 1 plus 2 plus 4 plus 2 to the power of n plus 1 is equals to 1 plus 2 plus 4 plus 2 to the power of n plus 2 to the power of n plus 1. So, by using the inductive hypothesis, we arrive to the quantity of 2 to the power of n plus 1 minus 1 plus 2 to the power of n plus 1, which is equals to 22 to the power of n plus 1 minus 1. So we have 2 to the power of the quantity of n plus 1 plus 1 minus 1. So therefore, we have proved that the statement holds for n and it also holds for n plus 1. And by the induction, then the statement holds for all n, which is element of n. Now let's look at the example number 2. Prove the following statement using mathematical induction. So let n be an element of the natural number, then the summation of k times k plus 1 is equals to n times n plus 1 times n plus 2 all over 3. So proof. We proceed using induction. We have the base case, n is equals to 1. So in this case, we have the summation of k times quantity of k plus 1 is equals to 1 times 2, and then it's equals to 2. So we substitute in the formula n times n plus 1 times n plus 2 all over 3. So we have 1 times 2 times 3 all over 3. So the inductive hypothesis, suppose for some n as an element of natural numbers, we have the summation of k times k plus 1 is equals to n times n plus 1 times n plus 2 all over 3. Now, the next step is the inductive step. Consider the case of n plus 1. In this case, we have the summation of k times k plus 1, which is equals to the summation of k times k plus 1 plus n plus 1 times n plus 2. So, simplifying, we have n times n plus 1 times n plus 2 all over 3 plus n plus 1 times n plus 2. This is by the inductive hypothesis. So, we have n times n plus 1 times n plus 2 plus 3 times n plus 1 times n plus 2. So, by further simplifying, we have the quantity of n plus 1 times n plus 2 times n plus 3 all over 3. So, by factoring out the n plus 1 times n plus 2. Therefore, we have that if the statement holds for n, it holds for n plus 1. Hence, by induction, the summation of n when k is equals to 1 of k times k plus 1 equals n times n plus 1 times n plus 2 all over 3 for all n is an element of n. Now, for the example number 3, we need to prove the following statement using mathematical induction. For all n is greater than 5 and for n less than 2 to the power of n. Let's proceed by using induction. For the base case, n is equals to 5. Then, for n is equals to 20 less than 32 is equals to 2 to the power of n, which the result is true. For the inductive hypothesis, we need to suppose for some n which is greater or equals to 5 that for n is less than 2 to the power of n. Now, the inductive step, we need to consider n plus 1. So we have 4 times n plus 1 is equals to 4n plus 4. And by the inductive hypothesis, we arrive at less than 2 to the power of n plus 4, which is less than 2 to the power of n plus 2 to the power of n. And since 2 to the power of n is greater than 4, and for all n is greater or equals to 5. So, the result is 2 to the power of n plus 1. Now, if the results hold for n, it holds also for n plus 1. Thus, by the induction, we have that for n to the power of n and for all n is greater than 5.
The principle of mathematical induction is a powerful tool for proving mathematical statements. By following the 3 steps of base case, inductive hypothesis, and inductive step, we can confidently establish the truth of an infinite number of statements. Thank you for watching our potent video on the principle of mathematical induction. We hope you found it helpful and informative.